Thank you. I'm going to talk about security, and I know you like it, right? So it's one of your most favorite topics that you like to address when you do work. Specifically GraphQL, the first thing that you think about, security, right? And actually, it's really complicated if you deep dive into it, because it's different from REST. And instead of like talking too much, I was going to show you like what's the issue. So here we have a small to-do application. So we store to-dos, we have a user, we can query it. I start, let's say, oops.
Can you make it bigger?
Well, let's see if this works here. Is this better?
Yes.
Okay. So let's see. Okay. So this is probably. I just need to. Let's see. So what we have a small to-do app. We can query to-dos. It's actually one to-do here. So we can create the to-do. Also, that works. Let's see, we should have two. So that's cool. So actually we're done, right? App works. That's cool. But now what we think about now is to say, hey, we actually need more. We want to set payments because our users should add a credit card number, like for posting something. So that's cool. No problem. Since we have a schema, we just say, oh, we store a credit card number with our user. Easy. And we need a new method called setPayment so that we can store credit card payments. Pretty easy. So now we need to adopt this implementation. So what we need to do first is we add a single credit card field to our user field. Cool, let's store it. And our resolver needs something new, which is called the set payment method. So we're going to activate it. Great. So that should work now. Let's see. This is something that happens with this when you run code in a browser, that it somehow loses old processes. So we need to kill it. Let's see. Okay, make serve. Oops. So what we are doing is we need to make generate. Of course, we changed the schema, so we're updating everything. So this is essentially rebuilding the Go server. And then once that is done, we already implemented the resolver. We changed the model in our user to store the credit card number. And we say make serve. So we run it. And of course, I was expecting this. So this is not cool. So
Something about projector and code.
yeah, exactly. So we fixed it, so that's fine. So we have now a set payment method, which takes the user, stored the payment. So what we're going to do is we also ask our own ID and now our own credit card number. Cool. So what we are doing now, so everything is working, right? So that was quick. So now where's the security problem? So we just added everything and it's great. Now we created to-do for user 1, and then we have a second user 2. So we ask it here. So we have, okay, we see the to-dos and the user. And now since it's GraphQL, I can also query for credit card numbers for every user. And the reason why this is because of the schema. So here we use one user type, and that's also referenced for the to-do itself. So actually, GraphQL has done everything right, and it's intended to work this way. But now when you do something and you change it in one area, you need to think about it because it affects maybe different things. So you really need to think about privilege escalation, and you need to think about exposing too much information. So I hope you now get an idea what we are going to talk about today. So that was the intro. So now we do a quick poll. Where do you once you have seen now the demo, what do you think? Where are you? Are you more oh, I'm chaotic, or basic, or pro? Let's start with chaotic. Who is I'm not sure what I'm doing. Okay. Oh, more than I expected. Basic, I'm good. Okay, cool. And who's pro? Who knew everything and can go home now? Okay. So actually, it's a really, really interesting thing that I was learning by using GraphQL, especially since it's so easy to forget about it. In REST, essentially, you had one call, one permission check, and you got the response. So pretty straightforward. But that is now a lot different. So who am I? I'm Chris. I'm CTO at Mondo, a new company that is doing vulnerability management for cloud containers and on-prem. And I'm working in security for more than 8 years now. I created some quite popular security projects, DevSec project, which is about server hardening, and Inspec, which is a compliance tool used in US government, Fortune 500 companies. And I was director of engineering at Chef Software, Ansible Chef, and you probably heard about it. So now I'm starting a new company called Mondo. It's about vulnerability management, so enough advertisement, so you join our access. So back to our talk. So we realized that security is hard, right? And we always think, hey, this other team is working on it. It's fine. It's cool. It's not. So you need to think about it. And when we talk about authentication and authorization, we really need to talk about two things. And when I started thinking about it, it's always super confusing because those terms are so close to each other that it's really easy to forget. And then also HTTP is using authorization to transmit authentication code, so it's even more confusing. So, but besides that, so authentication is who you are. So when you log into something, you're user X, you're John, you're Jane, and that's all. It doesn't say you have access or not. It's just saying who you are. And then based on that, you can make decisions have you have access to it or not. Think about you have two keys, and you can get in your office either with both keys, but in specific rooms, you can only use it with one or the other key. So those permissions are the same thing in software. So all cloud vendors, for example, need to have a really, really good authorization strategy since they are multi-tenancies, multiple users, multiple organizations, and they need to secure it, and it's really difficult. So we start talking about authentication because personally I think it's the easiest one. And then we are deep diving into authorization and specifically how you can implement it in GraphQL. So authentication, I'm really clear, use OpenID Connect. Don't use anything else. It's specified, it works, done. So just quickly how it works. So you need an OpenID Connect server. There are different services available. AWS has one. There's Red Hat Keycloak, open source. There are way more others. So that essentially is storing your users. And your UI essentially, you have experience when you log in with Google or log in with Facebook. They all use OpenID Connect behind the scenes. So you have your dashboard. You look into, when you do login, you click on login with Google, for example. And then it redirects to Google. You enter your credentials, and it's redirected back. So all cool. What happens behind the scenes is that your browser gets a token from that OpenID Connect provider, and there's an ID token and an access token. The ID token is for the UI, and the access token is for the backend. So the cool thing now is that the backend doesn't need to do user management anymore. It just gets a credential token, and then it's all. And with OpenID Connect, you can have, you just say, this is my Connect server, and it verifies everything with a signature. So it's all specified, all done. There are libraries out there. Trust me, invest this time. It's easier, just do it. There are like open source tools, cloud tools. Like here are some, there are way more others. Like here you have a link. Just do it. It's really the easiest thing you can do, and it saves you so much time because you don't need to think about security, credentials, like how do you store it, because for users, you need to make sure that passwords are stored secretly, and like it's a lot. So now we focus on what needs to be done in GraphQL specifically, and this is authorization. So now, let's assume we have implemented authentication, we have our OpenID Connect server, and all is cool, but our app still just knows I'm Chris. Great, that's not enough. So let's look into GraphQL spec, and it says, oh yeah, this is done in business layer. Cool. So nothing is done for me now, so I need to start from scratch. Is this even a problem? I was just quickly researching, so all we talked about, like from all published vulnerabilities, it's about 16% of vulnerabilities. So yes, it's a big problem, and you probably should deal with it. So this is internally how GraphQL works, and the question is like, it's not necessarily one program. It could also be split out. We heard API patterns. So one part is like your GraphQL server, could also be an API server. Then you have the resolvers, and then you have maybe internal business logic or even external HTTP servers. The interesting thing is that it could be in one process, or it could be split across multiple, but the architecture stays the same. And when you're going to implement authorization, you now have multiple options to implement it. So you can put it in here, you can put it in here, here, or here. And the question is, hey, Tracy, now where do I start? And actually, I try to go through every example to give you an idea like when you should use which one. Actually, let's go through code. So the first one is just a schema. So what this means, essentially, we don't care specifically about permissions. We just say, I only allow it if it's Jane or John, but they have all the same rights. So it's super easy. So what we're doing is we have our server. So you don't need to understand Go, but what this essentially is doing, it's starting a GraphQL server, and then before we're saying we want to do an authentication, so only authenticated users can use it. So in this case, we have here, we check it, we read the authorization header, and then if it fits, we let them through, otherwise we don't. Pretty straightforward. Let's try it out. So we have here, we have one token, so that is just preset here in our example. So only users with the token 1, 2, 3 can pass, others can't. So that's really straightforward. Let's see. So we have our to-dos. Okay, so let's see. Yeah, this is right. Also right. So this is cool about having the UI because it shows me something that I can fix. And viewer is also not there, so we don't need that. Okay, so no to-dos. So that's fine because like we have not stored to-dos. We just started the server and we put the right token. Like let's try something else. boom, like it doesn't let me through, so we can optimize the error message and all that stuff, but we don't care. So actually it works. So back to our, here we just implemented something in front of the GraphQL server itself, which checks the HTTP entry and says, is this user authenticated or not? If he is or she, then it is OK. We let them through. Otherwise, we don't. So it's one of the most simple implementation of authorization. And it works mostly for internal servers that you just use with a few users. But it's one thing to protect it. So it's where you can start, super easy, but also like very like granular, like it's really like not fine-grained. So, OK, let's see what we can do more. So we look into GraphQL server. So GraphQL itself comes with something that is called directives. So what are directives, in case you haven't heard about it? It's essentially the same example, but what we are now saying is we have some roles. So in this case, we have an admin and a user role, and we attach it to a specific methods in GraphQL. So we say, for example, here, like to-dos can only be created by administrators. Set payments, ignore that. That should be done by administrators too. But that's it. Everybody can read it. So now we have roles. So we distinguish between users who are administrators and who are not. OK, so let's start. Oops. Directives, make serve. So what we introduced here now in code is that we essentially have two users. We have John and Alice. John is normal user. Alice is administrator. And we have a new method which says, hey, has this user like admin, is it admin or not? So it checks the flag, and then it returns it. And the neat thing about implementing it in the GraphQL server, I don't need to change something in my implementation. I can do this up front, just say, if the role administrator is required, like it goes in here, reads the user, checks if the user has the rights. If so, great. Otherwise, I'm denying access. So essentially, let's see. We said John can John cannot create to-dos, but Alice can. So let's try that. So we have John is 1, 2, 3. So that should work. So he can see to-dos, great. Let's see if he can also create to-dos. So he can't because like he's not an administrator, right? So here we have also Alice. The token Alice is 1, 2, 4. Let's see if that works. Great, so that works. So everybody can like see now to-dos. Only Alice can create it because Alice is administrator. So every new user can be administrator and create stuff. Pretty straightforward. What we achieved now is that we now can distinguish roles. So it's not just on-off. We can now also have multiple roles. Really easy to implement. No core logic needs to be changed. As I demonstrated, it's really something that you just put in general to the GraphQL server, so it's upfront your implementation. So it's really easy to add. It depends on your implementation, if you're in Go or node.js or something else, but it's the principle is the same. It's really easy to add, and you do this in front of any resolver or any backend logic. So now, like we are more fine-grained, we have multiple roles. It's still pretty easy to add, but it is maybe not enough. So think about you have two customers on your software, and you have one administrator for one customer and one administrator for the other customer, so you're in trouble. So obviously, what we've just implemented is not enough because like we can only distinguish between administrator or not, but not administrator for customer 1 and administrator for customer 2. So you can create multiple roles for multiple customers. You can do that, but it depends on how much customers you're going to have. So it's a limited amount, probably good to start with, but otherwise you end up, we need to do more. So what can we do? When we're going to implement a resolver or look into it, we need something called role-based access control, for example, so things get more complicated. So let's look how this can be implemented. Let's see, we have the resolver, so let's close all this. So we are back to the original schema. So that's the wrong one. So here we remove the roles again. So since we are not going to implement it in the GraphQL server, so we need something else. So we implemented something that is called authorization module. So I've just done something for prototyping here. So there are way more stable libraries out there, but for demonstration purposes, this is much better. So no matter what kind of tool you use, you normally have a subject, action, and a resource. So resource is room 1, room 2. Action is I can enter one, or I can maybe open the window. And then the subject is the user that is coming into. So that is pretty standard. No matter which library you use, it's always the same. So that's why I'm just using this interface here, so you can actually change the implementation with whatever you like. So then we are saying okay, those are our facts. We're saying for all to-dos, both users can create it. User 1 can't create something, user 2 can create something. We can delete it or not delete it, but the person who can create it can't list it. It's an arbitrary permission management, but this is just how to demonstrate it. So let's see. We're going into resolver. So let's see. We're back here. So that's right. User 1 can't, user 1, 2, 3 is essentially John, who can list something, but he can't create something. So let's test that. So that's user ID is not defined by type, need to do, oh, actually that's right. So we changed a little bit more in the schema. So we need to remove that. So what is important here, that the implementation changes here a bit. We derive the user actually from that token, so we don't need this anymore. I'm going to publish the example, but so it's not super important in this case. But here we see that actually the user is not allowed to do something. And the reason why this is we see this here. It essentially said the subject, which is John, tried to create a to-do, and that was denied. And if we look into our resolver, we see here we first read the user, we get the user ID, we create the facts, which is I want to access the resource to-dos, I want to create a to-do, and this is my user ID, let's check if this works or not. And then based on that decision, I'm saying, oh, not cool or cool. And then I can do something. So based on that, we can see if Alice can do that. So she can create something. So that should now be here. That's fine. But again, Alice is not allowed to list something because here it's the list. Alice is subject to is not allowed. So let's test it. So no permission. So here you see that it got a lot more complicated now. We need an authorization framework. And that is not for free. So authorization means you need to check it with every call. It takes time based on your implementation. And so you do it more often. So now you do it per resolver. And this is here a pretty simple example. So it's just called once. But if you have more nested models with more nested resolvers, and you do permission checks in front of every resolver, it could be that one call in this UI creates like super many permission checks. That is actually okay, but also you need to make sure that this permission check is super, super fast, like really fast. So that means, like back to our idea, like we have now our logic in a resolver. We can do a lot more fine-grained checks, but we essentially get a lot more complexity that we need to manage based on performance checks. Like we need to make sure it's implemented everywhere, and we can still run into the problem that we have privilege escalations, since resolvers can like call other resolvers, and it's tricky. Because essentially, if you like think about it, you have two backend systems, and you just check it in one resolver. You just expose the model to something else, and the backend model is not checking it. You still have access to it then. So it's really easy to miss something. And it's depending on your needs, you may want to have it in your business logic. So GraphQL is more like the API gateway, and you don't check anything here, but you check it always at the latest state. But you like means it needs to be even faster, since more checks needs to be done. So let's look how this can be implemented. So we have the business logic. So what we are doing here, again, is the same model. But what we have done now is we created a new store. So essentially, it could be an external service. In this case, it's an internal interface. It doesn't really matter, but essentially you have an interface. I can create something, delete something, and list something. And this is pretty straightforward. It has nothing to do with GraphQL at this point. So it's essentially just a store. It implements like create, delete. It is doing permission checks, and it's all fine. The advantage of doing it this way is you can test this completely independently, super easy to test in the specific scope. The difficult is now you still need to test it with GraphQL. So when you do a resolver, the resolver is now super clean, because like what you're doing is I just say, hey, store, create something, store, delete something. I don't care about this user anymore, because I just pass it with the context into the backend, and the backend is checking it. So essentially what you're doing is when we look into here, like here we detect the user, we pass the user over here, here, and only here we're doing the permission checks. Okay. So let's see. Essentially, it's the same implementation that we had before, but as everything was moved to the specific model, so it's very good abstracted in a separate thing. So Alice can still not access it. Bob can. Let's see, this is right. And Alice creates a new to-do, and then we see it here. So now it's essentially the same behavior as we had before, with the difference that the checks that we had here in the resolver now move to the business logic. Disadvantage, you need to implement this in front of every backend, right? So as you already see, like this is the right solution. It depends really on your needs. So let's see. So essentially, like this is my recommendation, like where you can see what works best for what. So use an HTTP handler if it's just like you're the only user. You just want to make sure that nobody is using it outside in the public. It's super easy to implement, but it's also like on-off decision. The more you go right, the complexity is increasing, like really rapidly. You need to manage it, you need to test it, you need to verify it. There is good tooling out there, like really use an authorization library if possible. Sometimes it's not possible based on your needs. But also the granularity is like really like shrinking. So you can do it a lot more fine-grained, and it's normally something that you probably need when you have a cloud service, like you end up here. Don't underestimate this. I've actually implemented this at 3 companies now, and it's people have in mind that they want this tomorrow, and if you're not designing it in this way, you actually like need long. So I was when I was working at Chef, I was core part of building their like commercial product, and if you're not like putting it down, like product wanted to have this in 1 month, and I said never ever, and it took a year to have the full suite that product intended to have quickly. And this is because if you're not having the primitives by having everything prepared, like user management, OpenID Connect, and all that is missing, and backend is not prepared for it, like you have a lot to do. So normally you need to have the primitives, make sure user management works, make sure like you're prepared for authorization, start with simple authorization rules, like don't make this more complicated than you need to have, and then grow into the problem. So essentially, I think you pretty like much will quickly land here, and then you can like develop going forward in this area. Yeah, sorry, like I joined our early access, but that was the idea to show like how to implement authorization on different levels. I hope you got something out of this talk, and I'm open for question now. Sure.
So there was a question asked by you in the beginning of the talk. So let's say we have a user that appears in a different location in a GraphQL tree.
Yeah.
So let's say if I'm querying for a user directly, I can access credit card if I'm the user, right?
Right.
I'm the owner. And if I'm asking, let's say, for a shopping cart,
Yes.
then if I'm a manager, I can access credit card, right?
Yeah.
So now the check depends on the context.
Right.
So how would you solve this issue? How would you make it context bound?
So there are like one thing that we need to take away. So one example, like if we look how AWS and Google are implementing it, they normally don't distinguish between data itself. So think about lists of nodes or instances running in AWS. Like you can either see them or not, but you can't say, I can only see instances with tag X. So this means like make your granularity like that matches to methods. So from my perspective, get all instances, get like data X, get data Y, and separate them in a way that makes sense. So essentially try to avoid filtering data as long as possible. I'm not saying it's possible always, but you can like get pretty far in not doing it. And then create multiple methods, like with specific actions, like I can list, for example, in this case, list instances, or I can list credentials for instances. Those are 2 methods actually in the backend, and they are different actions, and therefore they can have different permissions per user. And then when you query something, and even if you have GraphQL and you have a resolver that depends on both methods, since it ends in the backend, like it's always checked no matter like where this is coming from. So if the user is access or not, it's always automatically derived. So think about this again. So let's say we want to fetch an instance, and one business logic is implementing a get me all instances, and the other one is like get me the credentials for those instances. So that what happens is GraphQL will resolve it. They'll figure out 2 resolvers, one that fetches the credentials, one that fetches the instances. So user data, like the user is passed through, it's checked here before the data is gathered here, like the permission is checked, even though it was one call from here. So you cannot have privilege escalation if you're like implementing it here, because even if the resolver figures out that there's like multiple calls in the backend, like backend checks it. If it fails, it just say, sorry, like you have no permission.
I think there might be a fifth stage where you want to actually authorize the user if they can access data or not. And I believe it's on the data layer itself. If you have a multi-tenant system, as you said earlier, that one admin can access part A of the data and another admin can access part B of the data. And I think it's not enough to check it on the resolver level. I think you have to check it on the per data level.
Yes.
You want to ask, does this user have access to this particular row in the database?
Yep, so this is when you implement attribute-based access control, which is healthcare, military, like you have that problem. So that is definitely more complicated. This is definitely also business logic. Like I would always do it here. Since implementing it here is risky, since you can still like escalate from the resolver and then potentially during a different schema model or somebody else added something to the schema, like it ends at this level and fetches the data. So you always want to do it at the latest stage. But then remember, like the more you do it here, the more speedy your permission check needs to be. Okay, so everybody's overwhelmed. It's complicated, but actually, like, you just need to grow into it and don't overthink it. Like, start with something, and then this gives you pretty good guidance where to start depending on your needs. Think about this first, like what is your need, and then start implementing, not starting with the most complicated solution. That's my general advice. Think before you do something. But it's possible. It's really no magic anymore. It's really well documented, and it's not like once you end over here, it's not GraphQL specific. Like there are like so many tools out there that can help you implementing it. OPA from the Cloud Native Foundation can help you. There are other specific tools for specific languages, frameworks. In Java, for example, there's a very good frameworks out there. So try to use something, if possible, that is established, since they have focused on like performance already. If you're doing it yourself, you better need to know what you're doing. It's tricky, but possible.